Is it possible to see the past just by looking at black holes in space? In a previous video, I talked about light bending in water. Since water has a higher refractive index than air, under precise conditions, light will follow its curve. A trick used in fiber optics, the tech that brings you the internet. Fun fact, Viganella, a small village in Italy, loses sunlight for 80 days each winter due to surrounding mountains. To deal with this, locals set up a giant computer-controlled mirror on top of a mountain to reflect sun into their village, so light can be absorbed, scattered, reflected, or bent. Besides difference in refractive indices, gravity can also bend light, or more precisely, heavy objects create a dent in the fabric light travels through. The heavier the object, the deeper the dent, and the more light bends. Black holes are the heaviest objects we know of. They are the result of a massive star collapsing on itself once it exhausts its nuclear fuel. If you compress Earth into a diameter of 2 centimeters, it will become a black hole. Their gravity is so strong that not even light escapes, which is why we can't see them directly. Instead, we detect them by watching how they influence nearby bodies. That's how we found a supermassive black hole at the center of our galaxy. Light carries information. You see people and they see you thanks to light moving around at the speed of 300,000 kilometers per second. With a finite speed, a somewhat delay will be introduced for very far away objects. We do not see the current sun, we see the one from 8 minutes ago, because that's how much time it takes for light to reach us from the sun. Now, since gravity can warp space, therefore bend light, when we look at regions where light bends around massive objects, we see distorted images of what's behind them, a phenomenon called gravitational lensing. It's like a cosmic funhouse mirror. What you see isn't where or how it really is. With a black hole, space-time is warped so intensely that light can loop around it in a ring called the photon ring before falling in. Imagine water swirling down a drain. That's kind of what happens to light near the event horizon, the point of no return. Now remember, light carries information, continuous images describing what's there, and Earth has been reflecting sunlight into space for billions of years. So in theory, if we had a magical telescope that could capture light trapped in a black hole's orbit millions of light years away, we might see Earth as it was millions of years ago. But reality isn't that simple. Black holes do not form a focused image. It's smeared and scrambled as it loops around. The light emitted from Earth is too dim. The image you see right now is Earth as seen from Saturn, a tiny blue dot. For your information, Saturn is slightly more than 1 billion kilometers away. In cosmic terms, that's peanuts. The closest black hole is 1500 light years away. At that distance, Earth's light would be drowned out by noise, stretched beyond recognition, and mixed with countless other photons. So while the idea is mind-bending, we have no way to precisely capture or untangle that light, at least not with any tech we know of.